Hello, everyone. Welcome to MobiSys 2021. I am Nirupam Roy from the University of Maryland, College Park. It is my immense pleasure to chair the session on localization and tracking. This has always been one of the core research topics in the wireless and mobile systems community. And if you try to trace back the origin of localization and tracking methods, you will have to go back to the time when probably the first ship was made to navigate around the ocean. But till today, it is a fresh and dynamic research space full with excitingly new challenges and opportunities. Every time a new technology is developed, a new modality is introduced to the systems research, they just find their ways to enrich localization and tracking methods and applications. In this video, I will very briefly introduce the research topic to you. So let's start with the definition. What does localization mean? Well, localization is simply finding the position of an object. Okay? Often applications also require the orientations of the object along with the location. And if the object is moving in the space, then keeping track of the changing location is called tracking. The definition may sound abstract to you, but I'm sure almost all of you are very familiar with at least one localization system. Yes, the Global Positioning System, or GPS, that can localize a GPS receiver and of course anything else that is this receiver is connected to anywhere on the earth. And if you are like me, you cannot imagine driving a car without a GPS system that localizes your car, so its position on the map and the path planning to tell you how to reach to your destination. Not only in the car, a GPS receiver in your smartphone helps us to find locations of our favorite restaurant, transit stations, and so on. So finding the location of an object, which is in this case, the GPS receiver, is not that abstract, right? If done well, it can solve real problems. It is needless to say that GPS has revolutionized the transport and navigation. But it is not the entire story of localization. The span and scope of this topic is much larger and its applications are much subtler than it appears. Some of you may find it surprising that interplanetary object localization and tracking of spacecraft far beyond the surface of the Earth share the same localization ideas as a GPS system, which also share the same technical building blocks with the localization of tiny insect-scale robots, which are opening up new dimensions in disaster management. Not only that, the device that can track the locations of your fingertip by sending a series of wireless signals and carefully analyzing the reflections to enable a new human-computer interaction, that also borrows principles of localization and tracking. A different applications of localization method can enable ball-by-ball analysis of a game by precisely tracking the locations and movement of the ball on the field in real time. However, when we take a closer look at these applications, which are made possible by decade-long research in this area, we find the diversity that calls for innovation to meet unique challenges. For instance, when your vacuum cleaner robot tries to localize itself with respect to the static objects in this room, that problem is way too different from localization of pedestrian and dynamic objects at high speed for autonomous driving. On the other hand, while low power techniques is not a priority in an autonomous car, the small robot will prefer to save energy from localization. Again, localization of hand and tracking hand postures using the inertial sensors of the smartwatch requires a different formulations of the problem than 5-digit hand gesture tracking using multiple infrared cameras for applications like teleoperated surgery. Smart speakers and voice assistant can localize a sound source that can run analytics on the acoustic environment. But localizing internal body sound and vibrations for continuous health monitoring brings in different sets of difficulties. Similarly, applications like localization of the chest wall for breathing rate detection fall detections of elderly person without requiring any wearable device, the monitoring of the movements through an occlusion, and many such applications further diversify the scope of localization and tracking. Now think of this unique application of drone light show, where a swarm of hundreds of drones creating different formations in the air. Naturally, each drone will require a fine-grained locations information with respect to the neighboring one in a dynamic environment like that to make this spectacular show possible. There are thousands of other applications that builds on innovative variations of localization and tracking methods to solve real-world challenges. In the MobiSys community, we are constantly pushing the boundaries of localization and tracking to create new opportunities, one paper at a time. This year, we have 4 unique papers to be presented in this session. The first is TerraLock. TerraLock is a low-cost wireless localization technique that applies signals angle of arrival based localization. It develops a platform that combines Wi-Fi, Bluetooth low energy, and LoRa devices for localization. Interestingly, this paper shows the use of only a single RF chain that switches between multiple antennas to avoid simultaneous sampling of the array element. The second paper, UVLock, shows that it is possible to accurately localize humans and robots in indoor environments using off-the-shelf wireless routers. The system works with a few access points and maintains its performance even when non-line of sight scenarios appear. The code for implementing the systems on off-the-shelf routers are made open source for the community to use it as a tool for further applications. The third one is Owlet. It is a miniaturized and low-power acoustic localization system that has applications in insect-scale robot navigation, on-body sensing, and many underwater monitoring solutions. The core idea is to break away from the traditional array-based techniques and explore the acoustic microstructure and statistical data-driven methods for finding the directions of arrival of sound. And finally, MMesh. This paper presents a technique to estimate the mesh representation of a human body in real time. It developed a deep learning method around the millimeter wave radar signals to create the 3D human mesh, which can track human body movements even through certain occlusion. We'll have intriguing discussion in this session, so please join us. Thank you so much for listening in.